Many people have seen how, in large stores, money was sent through pneumatic tubes using pneumatic mail. But did you know that in the 19th century, pneumatic subways operated in different parts of the world? And what do they have in common with Elon Musk's famous Hyperloop project? Let's figure it out. The Industrial Revolution in the 18th century led to many discoveries, including engineering breakthroughs that made it much easier for people to travel within cities and beyond. Steam engines gave a strong boost to industrial progress. The vast railway network allowed Great Britain and several European countries to efficiently manage their colonies. Great Britain could afford to wage a deeply entrenched opium war against the Chinese Qing dynasty. But what was an incomparable advantage for war became an obstacle for urban transport. After all, steam engines have their drawbacks: noise, dirt, and their bulky size. Plus, you also had to carry fuel with you. People started thinking about an alternative to the steam engine. At that time, engineers offered 4 options. The first is the electric engine, which is gaining popularity today. But if today manufacturers face issues with their efficiency and profitability, then imagine what it was like in the 19th century. The second is the internal combustion engine design, with a different, low-emission and less noisy gasoline or diesel engine. But again, the internal combustion engine of the 19th century was still underdeveloped and was also very expensive. The third is similar to a cable car system. You can install an engine at the cable station and stretch cables from point A to point B. A silent and inexpensive option. On the London-Birmingham and London-Blackwall railway lines, cable railways once operated alongside steam locomotives, competing with each other. But a cable can't stretch for hundreds of kilometers. It would get twisted and worn out repeatedly, and overall, it's not as economical as a steam engine. With the advent of electric locomotives and locomotives with internal combustion engines, cableways were used only in certain scenic locations. And it seems that's exactly where they belong. And finally, the fourth solution is the pneumatic tube system. You don't need to install an engine in the carrier, run annoying wires or cables. You just need to pump an airflow into the tube. The basic principle of pneumatic tubes was first proposed back in ancient times, but it was only in the 19th century that it began to be put into practice. For example, the Scottish inventor William Murdoch created a pneumatic device that used compressed air to deliver notes through a tube to a remote recipient. A London craftsman named George Medhurst was one of the first to appreciate the potential of such systems. He outlined his ideas about their practical application in a brochure with a rather concise title, Calculations and Remarks, proving the feasibility, efficiency, and advantage of implementing a plan for the rapid delivery of goods and transportation of passengers through a 9-meter tube using the power and speed of air movement. He described a huge stationary steam power plant capable of generating pressure, power sufficient to make a carriage move at a speed of 80 kilometers per hour, with a fuel consumption of 36 kilograms of coal per 6.8 kilometers. At a time when the most common means of transportation were either walking or horses, ideas like this were cutting-edge innovations. George Medhurst realized that not everyone would enjoy spending long hours in dark tunnels, so he came up with an alternative that would later become known as the atmospheric railway. He suggested that alongside the regular ground tracks, a 30-centimeter wide iron pipe with a slit seal running along its entire length could be laid. At the same time, smaller pneumatic tubes found their use in exchanging messages between the central office of the London Telegraph and the Stock Exchange. The newly formed London Pneumatic Transport Company began installing iron pipes in the ground for transporting mail cargo. With the help of these tubes, carts the size of a coffin moved between London post offices at a speed of almost 2 kilometers per hour. One of the supporters of underground transport was an unusual man, Alfred Ely Beach, known as the inventor of the typewriter for the blind, the founder of a school for freed slaves, and the editor of Scientific American. After hearing about his London colleagues' successes, Alfred Beach became a leading supporter of pneumatics in the U.S. to raise public awareness about pneumatic technologies. In 1867, he funded the construction of a 30-meter wooden tube through which people could travel from one side of the American Institute's exhibition hall to the other. Alfred Beech outlined the advantages of pneumatic locomotion in his treatise Pneumatic Dispatch with illustrations. This is what an advertisement for a pneumatic subway ride looked like. Like most other inventors of high-speed transportation, Beech hoped to create a route along Broadway, since this street was the busiest in Manhattan. However, he faced opposition from Alexander Stewart, the richest merchant in the United States. Stewart's magnificent marble palace was located right at the intersection of Broadway and Chambers Street, and the man did not want any unsightly structures to inconvenience him and his wealthy, influential patrons. A familiar story, isn't it? At the end of 1868, Beech's Pneumatic Transit Company leased Devlin's clothing stores on Broadway for 5 years and began construction. The details of the project were kept secret, but its scale was impossible to hide because of the huge equipment outside the building and the many horse-drawn carts that carried away tons of earth every night. On February 26, 1870, Alfred Beech finally unveiled his secret tunnel to the public. One of the popular journalists of that time called the event a fashionable gathering in the depths of the earth. Visitors descended into the basement of the store, the scale of which was limited by the equipment, but there were special doors. The inner door would not open until the outer one was closed, and it served as a simple airlock for pneumatic pressure. The interior of the foyer was done in the finest traditions of high society. It had wooden paneling, ornate candelabras, an elaborate fountain filled with goldfish, and a grand piano. For just 2 coins, anyone could take a ride in the pneumatic carriage, which could hold a total of 20 passengers. A huge fan weighing 50 tons was located in a neighboring chamber, separated from the foyer by a long corridor. The height of this giant was 6.4 meters, its length was 4.9 meters, and its width was 3.7 meters. It consisted of 2 huge longitudinal blades and a special set of adjustable partitions, which allowed switching between suction and blowing modes without reverse rotation. In the first 2 weeks after the launch of pneumatic transit, Beech's company sold more than 11,000 tickets and received a lot of praise from the press and the public. A couple of years later, Beech's company was no longer able to pay for the rent of the basement of Devlin's clothing store, and the entrance to the tunnel had to be bricked up. In September 1878, Alfred Beech stepped down as president of the company and switched to other projects. He died in 1896. 2 years later, the Devlin's clothing store building, along with the abandoned foyer, was destroyed in a major fire. However, in 1900, it was rebuilt. The hastily built brick wall was replaced with a solid concrete slab, leaving only a ventilation shaft leading to City Hall Park as the only way to access the prototype pneumatic tunnel. The experimental transit by Beech was forgotten, and not mentioned again until 1912, when the Public Service Commission decided to dismantle the tunnel to clear the way for a new electric subway line. Inside, they found rusty rails and a pneumatic tube in fairly good condition. The cars that carried passengers were a bit dilapidated, but still retained traces of their former luxury. Today, the City Hall station of the New York subway covers the entire area once occupied by pneumatic transit. During the construction of the new station, the tunneling shield and one of the passenger cars were dismantled and removed for preservation, but nothing is known about their further fate. By the end of the 19th century, all pneumatic transport had been forgotten. The tunnels were abandoned, and all technical patents were, so to speak, shelved. It is considered quite natural, so to speak, the natural order of things and a systematic change of technological paradigms. However, there are conspiracy theories that around the same years, Tesla's wireless energy was banned. According to the logic of this scenario, it was not profitable for the so-called masters of money to use advanced technologies because they risked losing their power. Imagine an alternative reality where Tesla's wireless electric energy merges with pneumatic transport projects. What would that world look like then? Maybe something like this? These are scenes from the movie Kingsman: The Secret Service. Under every reasonably large city, there are multi-kilometer tunnels stretching out, and their size is surprisingly similar to what is shown in the movie. We are told that this is a typical example of medieval sewage systems. Such gigantic and excessive tunnels for waste drainage existed in every reasonably large city. But, of course, this is just a theory. And whether to consider it credible or just a silly fantasy is up to each person to decide. After all, our world went down a different path. The path of using fuel-based energy, which is derived from fossil fuels. It's only natural that all pneumatic transport construction projects are unprofitable, and no one is interested in developing them. But here's something else. This map has circulated online for a long time. It shows 130 underground military bases connected to each other by tunnels. Of course, all of this looks like a crude fake, since the texts that accompany this picture claim that this map, which is famous all over the internet, is highly secret. And through these tunnels, highly secret pneumatic trains of U.S. secret services and agencies move in utmost secrecy, traveling using magnetic levitation at incredible speeds of several thousand kilometers per hour. And for constructing such tunnels, various types of tunnel boring machines are used. This, for example, is the nuclear tunnel boring machine, which melts solid rock and leaves the walls as smooth as glass. But maybe there's some truth in these semi-fantastic theories? After all, after 2 world wars, a boom in technological progress, and a huge amount of time, someone once again took up the idea of pneumatic transport. And that someone is none other than our old friend Elon Musk with his Hyperloop project. The history of this project began in 2013, when Musk proposed a futuristic transportation system that, according to the entrepreneur, would replace the outdated idea of the railroad. In the alpha concept published by Musk, the movement of capsules through the tube was made possible by linear magnetic acceleration. To put it simply, the principle of movement is comparable to maglev trains, which are named after the abbreviation of the words magnetic levitation. The first commercial maglev appeared back in 1984 in Birmingham, UK. It linked Birmingham International Airport with a city station. According to Elon Musk, the ideal modern transportation model not only provides high speed and safety, but is also an environmentally friendly and affordable alternative to existing modes of transportation, to cars, airplanes, ships, and does not interfere with other transport on the same route. Hyperloop is a series of capsules that resemble airtight containers. The capsules move through a tube in an almost complete vacuum, where the pressure is 1/1000th of normal atmospheric pressure. This tube reduces air resistance, allowing the Hyperloop to reach high speeds. The movement of the Hyperloop can be divided into 3 stages. 1. Acceleration. 2. The thrust force in linear motors, which are placed inside the tube at certain intervals, causes forward motion by creating a magnetic field and transferring momentum to the generator inside the capsule. Levitation. The magnetic field lifts the capsule, and the thrust force accelerates it to a speed of 1,200 km/h. Deceleration. The thrust force changes direction and reduces the speed of the capsule. Kinetic energy is converted into electricity, based on the principle of regenerative braking, and charges the battery. 5. Deceleration. To reduce cost and the amount of energy consumed, developers tried to move away from magnetic levitation and came up with another way to move the cabins, using an air cushion. To make it easier to understand how the system works, scientists compared the movement of the capsules to the way a puck moves on an air hockey table. The only difference was that the capsules would not float on a cushion of air, but would move along it using electromagnetic pulses powered by solar energy. But this idea had to be abandoned due to potential risks of losing control, and the developers returned to using magnetic levitation. But, as with many of Musk's projects, problems and questions arose. Former Cornell University chemist Phil Mason talked about the shortcomings of Elon Musk's concept. He vividly explained how the Hyperloop system, in the event of a minor malfunction, could turn into a journey inside a gun barrel at bullet speed and result in the death of all passengers. To clearly demonstrate this threat, the scientist created a model of the transport using a glass tube with the air pumped out and a metal ball. Mason's experiment showed that even minor damage to a single capsule could lead to depressurization, which would catastrophically change the pressure throughout the entire train, turning it into an uncontrollable bullet. The Hyperloop will be so fast that in an accident, passengers would not survive. From a technical standpoint, some researchers also question the potential speed of the Hyperloop. Experts believe that traveling at 1,220 km/h could cause passengers unpleasant and frightening sensations. Nevertheless, the first passenger test of the Hyperloop prototype showed that the system is safe. There have been repeated debates about the cost of the technology. According to Elon Musk's calculations, building the Hyperloop system from Los Angeles to San Francisco would cost less than $6 billion. Nevertheless, in 2016, Forbes published information that, based on leaked data, the cost of Hyperloop 1 to San Francisco could reach $13 billion. That's twice as much as Musk estimated. However, many believe that even this price is underestimated, and the estimated construction cost is much higher, about $100 billion. Before inviting the first passengers on a journey aboard the train of the future, Hyperloop 1 conducted about 400 tests in the Nevada desert, not far from Las Vegas. People boarded the futuristic transport for a ride only in November 2027 years after Elon Musk shared his idea with the world. The first passengers of the Hyperloop prototype capsule Pegasus were Virgin Hyperloop co-founder Josh Giegel and Director of Passenger Experience Quality Sarah Luchan. The capsule with passengers covered a distance of 500 meters in 15 seconds at a speed of 160 km/h. The passenger test received a lot of criticism online. People began to discuss the innovativeness of Hyperloop and magnetic levitation, which allows the transport to move through tunnels. One of the users even called Musk's system the worst high-speed railway in the world, comparing the development of Hyperloop to the launch of the Mallard steam locomotive in England back in 1938, which reached a speed of 203 feet. Some recalled the world record of the Japanese maglev, which in 2016 accelerated to a speed of 603 km/h, and the first trains operating on this system could carry hundreds of passengers at a speed of 482 km/h, already in the 1970s, almost half a century ago. That is, as critics of Musk's concept say, Hyperloop is, to put it mildly, not an innovation. But if the entire project depended only on Musk, then the future of pneumatic transport would be very uncertain. For example, as with the Boring Company tunnels to the Future project. These tunnels were touted as a solution to road traffic jams, but eventually, traffic jams formed inside the tunnels too. But after publishing his idea, Elon Musk decided not to patent the project, but to give anyone the opportunity to participate in the development of Hyperloop. That's how companies like Virgin Hyperloop and Hyperloop Transportation Technologies emerged, which continue the idea of Hyperloop. Many of those who are developing Musk's concept also work in large corporations like Boeing, Yahoo, and even NASA. Technology development occurs in small groups, with participants assigned based on their interests and skills. Communication during work happens mostly via email, but once a week, the teams meet for online discussions. Perhaps, in the distant future, humanity really will move around using a system of pneumatic tubes. If that wonderful day ever comes, then Mr. Alfred Beech's experiment can finally be considered complete. What do you think? Will Elon Musk and other companies be able to implement this project? Share your thoughts in the comments, and see you in new episodes on our channel.